Good day once again. You are welcome to episode 36. Episode 36. We want to continue on our circle theorem. We have already proved theorem 1 and theorem 2. We want to look at theorem 3. Angle formed from diameter touching the circumference of a circle is always at 90 degrees, or invariably you can say that angle formed from a diameter of a circle touching the circumference is always at right angle. We want to show that x, the angle touching the circumference, is always 90 degrees. Let's have this shape in this format, assuming that this is the diameter and this is the center of this circle. So we have this shape. This is that angle we are looking for. So the angle at the center here, reflex angle here, is 180. Reflex angle at that point, or angle on the straight line, is 180 degree. And according to, so if this place is 180 degree, according to theorem 1, says angle at the center is twice angle at the circumference. So if that is the case, that means if this one is x, that means angle at the center 180 is twice angle at the circumference 2 of what? X. If we now make, that is according to theorem 1. If we now make x the subject of the formula here, so that means x is equal to 180 divided by 2. Therefore, it is 90 degree. Then x equals 90 degree. Proof. So any angle you form from diameter touching the circumference of a circle is always at right angle, or 90 degree. Let's move to theorem 4. Opposite angle of a cyclic quadrilateral are supplementary. What are supplementary angle? Supplementary angle simply means the sum total, which is 180 degree. If it is complementary angle, you have it as 90 degree. So we want to show that x plus y, where x and y are the opposite angle of that cyclic quadrilateral. What do we mean by cyclic quadrilateral? This is a given shape that touches the circumference of a circle in 4 different places: A, B, C, D. So now we want to show that these opposite of it are supplementary. So let's assume that we have the center of that circle again. So if we draw a line this way and join it with this is radius of that circle, since this is the center. Again, we can look at this angle. Let's call this angle theta. So if we call that angle theta, that means this reflex angle will now be 360 minus theta. So we have this angle, we have this angle. If we look at this angle with this, we can use theorem 1 again. That means theta is equal to 2 of what? X. Angle at the center is twice angle at the circumference. So if the angle at the circumference is x, that means theta is 2 of it, according to theorem 1. Theorem 1. That is why I arrange this theorem according to this, so that I can be referring to that theorem. Again, if I look at this one, that same 360 minus theta, let it be this place. So that means 360 minus theta will be equal to 2y. Angle at the center again is twice angle at the circumference. If that is the case, you said let our theta now to be equal to 2x. So let's bring it in. That means 360 minus 2x should be equal to 2y. So if I bring this one here, I will have 360 equals 2y plus 2x. Then I can now say that 360 equals to 2 into y plus x. So if that is the case, then y or x plus y will be equal to 180 degree. Proved. Proof. Very simple and straightforward. We can see that addition of x and y will definitely give us 180, which is supplementary. So by next episode, we are going to look at theorem 5 and theorem 6. Thank you for watching. Please ensure you subscribe to our channel, and at the same time you share the link to as many as possible, especially students in senior secondary school 2 that need this theorem as fast as possible, because they will be applying it in most of their questions that pertaining to circle geometry. Thank you till episode 36. Sorry, episode 37.